Let's look at a few different examples of Grignard reactions. So the first problem that we have here is just some straightforward Grignards reacting with aldehydes or ketones. In this particular reaction, it's useful to think of the Grignard reagent as just a carbon with a negative charge on it. So what I'm going to do is redraw the Grignard reagent, leaving off the MgBr and adding the negative formal charge on the appropriate carbon. And then we want to keep in mind that this negative formal charge, lone pair of electrons, is going to be attacking the carbon of the carbon-oxygen double bond and opening up that double bond. So let's sketch out what that's going to look like with our carbon skeleton. The carbon-oxygen double bond is now a single bond, and we have created this new bond between the carbon of the carbon-oxygen double bond and the negatively charged carbon of the Grignard reagent. So we're going to add that Grignard reagent R group right there. Now, temporarily, this puts a negative formal charge on the oxygen atom, and then that gets fixed with this water in step 2. Kind of hard to draw the mechanism on a condensed structure like that. And this gives us an opportunity to kind of draw this in a way that looks a little bit prettier. I'll leave that hydrogen on there just in case it's confusing. There's the product for this reaction right here. Let's take a look at our next guy. Again, we want to think about the Grignard reagent as not having the MgBr. We want to think about it as having a negative charge on this carbon right here. And that is going to be attacking the carbon of the carbon-oxygen double bond. So let's draw what that molecule looks like. We have created a bond from this carbon right here to this carbon right here. It's really easy to screw up. I think I may have just screwed up the number of carbon atoms in a Grignard reaction. It's sometimes going to be really useful to put some numbers on your molecules just to make sure that you're not adding an extra carbon. That O- is going to get protonated by step 2 water. This gives me a chance to really draw this nice and pretty. 3, 2, 1, 4. Definitely not IUPAC numbers. And here is our last one. We want to think about this as a CH3 minus. That CH3 minus is going to be attacking the carbon of the carbon-oxygen double bond. That is going to be putting an OH group on that carbon and an extra CH3 group on the carbon. We'll put some numbers over here. There's carbon number 1. Here's carbon number 2. We'll call this guy carbon number 3, like that. Not only do Grignards react with aldehydes and ketones, they will also react with an ester. Here is a Grignard reacting with an ester. We're going to go ahead and draw the mechanism for this reaction. Remember that we want to be thinking about the Grignard as an R-. Let that attack the carbon of the carbon-oxygen double bond. This reaction is going to be really similar to doing a reduction on an ester. So there I have added the Grignard to the carbon-oxygen double bond, opened up the carbon-oxygen bond. We have a negative charge on the oxygen. Just like if we were doing a reduction, we're going to reclose that carbon-oxygen double bond and get rid of the OR group as a leaving group. So this is going to temporarily form a ketone. That ketone, as we just saw up here, ketones are very reactive towards Grignards. So that means a round 2 Grignard reaction is going to happen. Attacking again the same spot, the carbon-oxygen double bond. Open up that bond. Now we have added a second CH3 group, like that. And then the last thing that's going to happen, this is where we have the step 2 H2O. The negative charge on the oxygen, grabbing that hydrogen and finishing the reaction, giving us an alcohol. Last but not least, Grignards can react with carboxylic acids, but not necessarily in a way that we would expect. So down here, we're going to draw the mechanism of the Grignard reacting with this carboxylic acid. Grignards are just super strong bases. So if we have a carboxylic acid present or anything that is even remotely acidic, all that's going to happen is that the Grignard is just going to go after the hydrogen, the acidic hydrogen in the molecule. So it's just going to deprotonate the carboxylic acid and leave us with a protonated Grignard. It's typically not what we want to do. Now let's take a look at some reactions where we are actually being asked to synthesize an alcohol from a Grignard. So in this particular situation, this we would call a retrosynthesis. Usually there are multiple correct answers to this type of problem. So I'm just probably only going to show you one way to do this, but keep in mind that there is more than one way. When you are being asked to synthesize a Grignard from synthesize an alcohol from a Grignard, come up with a way to synthesize an alcohol, what you need to keep in mind is that the Grignard reaction does not create the carbon-oxygen bond. It converts the carbon-oxygen bond from double to single, but it doesn't create it. So that means that the carbon-oxygen bond in your alcohol, that bond was always present. It did used to be a carbon-oxygen double bond at one time. So the carbon-oxygen single bond used to be a double bond, and that hydrogen that's on the end of the oxygen, that did not used to be there. The Grignard reaction creates a carbon-carbon bond between the carbonyl carbon and any other carbon in the molecule. So literally any one of these R groups could be added in the Grignard reaction. I'm just going to pick this one right here, just for no particular reason. So what I've done here is I've just kind of broken the molecule apart in my head. And I'm going to redraw this in a way that's like really ugly. So there's the part that I have in the blue box, and I'll keep it in the blue box just for consistency. With this bond, I'm going to make squiggly because that's the bond that we're breaking. And then the other part of the molecule that I've drawn, which looks like this. And again, it's really ugly looking, but that's okay. So that's this piece of the molecule right here. This is the ketone that we would use to make this particular reaction. And this portion of the molecule is the portion that comes from the Grignard. So where we have that squiggly line, this is where we actually need to have the MGBR or whatever substances you're using to make the Grignard. So this is the ketone and the Grignard reagent that could be used to synthesize this particular alcohol, or what used to be an alcohol before I wrote over the top of it. Now again, this isn't the only way to do this, but this is just the way that I chose to do it. And the question says it does want us to show how the Grignard is formed. The Grignard is formed from the alkyl halide, so instead of MgBr, just Br, with magnesium in ether solvent. And then don't forget in this reaction, the step 2 of the reaction requires us to use some water to finish the protonation. And just because this is driving me nuts, I'm going to rewrite that in a way that looks a little bit more normal. Let's practice again with this next problem. So again, we're going to start by remembering that the Grignard reaction does not create the carbon-oxygen double bond, but it does convert it from a double bond to a single bond. So this used to be a carbon-oxygen double bond, and this hydrogen did not used to be there. The Grignard reaction creates a carbon-carbon bond between this guy and anything that it's attached to. In this particular molecule, there's only one option. This right here is the only carbon-carbon bond, so that is the one that we have to add in this Grignard reaction. So again, I'm going to redraw the portions of this molecule. Here's the part that's in the blue box. This is the part that we're adding via the Grignard reaction. I'm going to go ahead and put those squiggly line there. That's the bond that we are making in this reaction. And this is our ketone right here. That looks super funny the way that it's drawn. If I put the hydrogens in place, it makes it look a little bit more normal. So again, this is our Grignard. Let's replace that squiggly line with the line to the MgBr. And also, again, we're supposed to be showing how that Grignard is formed. It's formed from the halogen, the halide, reacting with Mg in ether. And then don't forget our step 2 water.